Assalamualaikum. We are students from class L01 P3 and our group members is Hanin, Shazwani, Sabreena and Asyikin. So we're gonna do a case study of chapter 4, which is fluid flow in pipes and conducts. So we choose the Bernoulli's principles in this chapter. So Bernoulli's principles definition is when the fluid velocity increase, the pressure exerted by the fluid decrease. This principle can be derived from the principle of conservation of energy, which is sum of all energy along the same streamline is the same. So the sum of kinetic energy, potential energy and internal energy remain constant at the same streamline. So the example is when speed increase, the kinetic energy increase occur with simultaneously decrease in potential energy and internal energy.
So we have go through the definition of Bernoulli's principle. So here is the equation of Bernoulli. So the equation says energy per unit volume before equals to energy per unit volume after. So this is the general equation of this principle. So the equation is P1 plus 1 over 2 rho V1 to the power of 2 plus rho GH1 equals to P2 plus 1 over 2 rho V2 to the power of 2 plus rho GH2. So what is P? P is the pressure and plus 1 over 2 rho. Rho is the density. V1 V to the power of 2 is the volume. So it says kinetic energy per unit volume. So plus rho G. G is the gravitational force. H is the height. So it's for the whole this it says potential energy per unit volume. So for the so the example of the application is in the airplane, the aerofoil of aeroplane.
The main way that Bernoulli's principle works in air flight has to do with the architecture of the wings of the plane. Okay, how does it works of the aerofoil is there are two parts of aerofoil, which is top and bottom. Okay, for the top is the curved shape and the bottom is the totally flat. Okay, now for the bottom, allows the air to move slower, which creates more pressure on the bottom. Okay, then on the top, which is the air allows for the air on top to move faster, which creates the less pressure. So this will make the planes to fly. A plane also acted upon by a pull of gravity in which oppose the lift, the drag and also the thrust. Okay, for the thrust, the force that enables the airplane to move forward, while the drag is a resistance that opposes the thrust to force.
The problem for this airfoil is how to slow down a plane while landing. So there is some solution for this problem. Firstly, the higher the flaps configuration is, the more drag it will provide. Secondly, we have to raising the nose attitude will increase the lift-induced drag. Hence, it will slow down the aircraft. And lastly, we can reducing the engine RPM or the power. Solution, we will raise the flaps on this plane. So when the flap rise, the velocity at the top will low and it will make the pressure high. So when the pressure at the top will be high, so the pressure at the bottom part will be low in pressure.